All right, we're back. This is Math 200. We're looking at Chapter 7 notes. So we're going to finish it off with 7.7. I'm going to explain complex numbers to you. So, complex numbers, also known as imaginary numbers, are the result of when you take the square root of a negative number. And so, basically, this is what you have to know. I squared is equal to -1. And so keeping that in mind, anytime I have an even root, I need to replace negatives with I squared. So this becomes 25I squared. And now I just do it like how I would do that if it was a variable. If it was 25x squared, the square root of 25x squared would be 5x. Since it's 25I squared, I take the square root and get 5I, knowing that I is the complex number, imaginary number. Now, they didn't just, well, I guess all math is made up, but this goes all the way back to the fundamental theorem of algebra. If I give you a second degree thing, you find me two solutions, real or imaginary. And this is built into the algebra. They've actually come up with a lot of real life applications of imaginary numbers also. And so it's kind of a bummer of a name that it got saddled with imaginary. In mathematics, we call them complex numbers or complex solutions. So if you're doing any kind of aerodynamics, which is relatively new, you know, first plane 100 and so years ago, right, where they started flying commercially, 1920s. Aerodynamics, you use almost exclusively complex numbers. Also, if you're doing any kind of circuitry work where a charge is held, like a capacitor, that's also used. So, all right, enough about the background. Let's do the math. So here we've got the square root of 32I squared. We're going to split it into perfects and leftovers. So the perfect in there is 16I squared. The leftover then is 2. And so this is 4I square roots of 2. All right. The opposite of the square root of -121. Now do not make this mistake. Many students go, oh, a negative times a negative is a positive. That's just the square root of 121. That's 11. Many students are wrong. We have to deal with the negatives first. Remember, this is -1 times. So we're going to deal with this power first, which is going to be 21I squared, which is -1 times 11I, which is -11I. All right. Same deal with this. Now, I know, we've seen these already where you just do all under the same roof. The square root of 3 times 5 is the square root of 15. We don't get to do that. When we have even root, so an even index and a negative inside, the first move has to be this. All right? And so now I can get that I out of there. I square roots of 3 times I square roots of 5. And so now I times I is I squared square roots of 15. And then I squared is -1. So this is the correct answer to that problem, not just the square root of 15. So that the square root of 15 is a common error that happens a lot of times that people do. So careful not to do that. Same deal here. I can't just take 5 into that. Let's deal with the imaginary first. So we got I squared, 125, I squared under the square root sign, and then square root of 5. So let's fix that on the top first, and then we'll see what it plays out to be. Perfects and leftovers, that is the square root of 25, I squared, times the leftover would be the square root of 5, or the square root of 5, and then that is 5I, and the square roots of 5's cancel. So just plain old 5I. right. Okay, let's look at the next page. Multiplying. So this is going to be a pleasant, hopefully, experience for you with imaginaries in comparison to some of the other things we've covered in this chapter. These are a little easier. So 8i times 7i and 5i times quantity 4 minus 7i and 6 minus 3i times 7 plus 4i. Okay. Oh, and adding. Sorry. There's a couple of add problems up on the top. I jumped to multiply. So these are the first ones. 4 plus 6i plus 3 minus 2i and 8 plus 2i minus 4i. So these are easy peasy. Let's do those first. Let's do the easy peasy one. This is just combining like terms, just like if this were a different variable, if that was x. You just take those and add them together, 7, and you take 6i and minus 2i and make it plus 4i, and that's it. You're done. That's all. 7 plus 4i. So just combine like terms and treat it just like a normal variable. Same deal here. 8 minus 2i. Done. So nothing for the 8, so we just put the positive 2i with the negative 4i and get negative 2i. All right, when I multiply this, that's, what is that, 56 I squared. And then I squared, remember, is always just negative 1. So that's negative 1 times 56. That's just negative 56. Done. 20i minus 35i squared. So this is 20i minus 35 times negative 1, which is 20i plus 35. Done. I think in the book they want you to write it the other way around, like a plus bi, which I don't care for my tests. I don't care which order you write it in. But on the online, they probably want you to enter it like this. It's the same thing. They just want the number first and the imaginary second. All right. And then the last one on that page, we do 42 plus 24i minus 21i minus 12i squared. And so we can combine these two together, right? That's 42 plus 3i, and then actually plus 12, because that was minus 12, but remember that was times negative 1. So negative 12 times negative 1 plus 12. And now we can put the 12 with the 42. So our final answer is 54 plus 3i. All right. Okay, well then let's look at how do we fix it if they're on the bottom. Just like how we rationalize the denominators with square roots and cube roots, we can fix it so there's no imaginaries in the denominator. So here, let's look at two examples of this. We've got 6 plus 2i over 4 minus 3i. And then the other one is 5 over 6i. Let's do the second one first. Let's do these out of order. So the second one first. This one, if I multiply top and bottom by I get 5i over 6i squared. And so then I squared is negative 1, 5i. That 5 doesn't look very good. 5i over 6 times negative 1, or just plain old negative 5i over 6. Or 5i over negative 6. Doesn't matter where you put the negative. All right? This one is a little tougher because we can't just multiply by I. If we multiply the bottom by I, we have to distribute, and then I end up with 4i. So this one, we have to actually do conjugate. So I'm going to multiply by its conjugate. That is 4 plus 3i. And now let's see how that shakes out. The top is going to be a big mess. 24 plus 18i plus 8i plus 6i squared. But the bottom is going to be 16 plus 12i minus 12i minus 9i squared. So top skis, let's see what we got. I squared is really -1, so that's -6 and 24. I can put those together and get 18 plus 26i. And then on the bottom, those i's cancel. -9 times -1 is +9, so that's 25. And I think that's where the show stops. 18 plus 26i, all over 25. Oh, online, when you're doing these, they wanted a plus bi, so they want you to write it like this. 18 25ths plus 26i 25ths. They just want you to split up the band, so enter it like that when you're doing the online problem, because they're really sticklers about that a plus bi. All right, and then the last page, if you look at the bottom of 23, I squared is -1. I to the third is -i. I to the fourth is +1. All right, I is just I. So keeping that in mind, basically every time you have 4 i's, you've got yourself a +1. So on this last page here, we'll make quick work of these. And again, this isn't going to end up on any tests. I'm just explaining it so you've had exposure. Again, this becomes a bigger deal when we get into college math. So look, this is 1 over I to the 17th. But now, every 4 become 1. So look, if I think of this as I to the 16th times I, that's I to the 4th times I to the 4th times I to the 4th times I to the 4th, or 1 times 1 times 1 times 1, or just plain old 1. So I to the 16th is really just 1. So this is 1 over I, and that's it. And you can do that with all of these, like I to the 52nd times I to the 1st. That's 4, right? 13 4s, basically. And so I to the 4th, I to the 4th, I to the 4th, 13 times. It's 1 times 1 times 1 times 1 times 1 times 1 times 1, 13 times. So it's just 1. So this ends up just I to the 24th, that's even 4. So every 4 i's creates a +1. So it's just 1 times 1 times 1 times 1 times 1, 6 times. So that's just 1. I to the 125th, again, I to the 124th is divisible by 4 evenly, right? 31 times, so that's 1 to the 31st power times I. Just I to the 11th is actually I to the 8th times I to the 3rd. Well, let's think about that. That's I to the 8th. That's 1 times I squared times I. So I have 1 times -1 times I. That's -I. I to the 226, that's I to the 224 times I to the 2nd. So this is 1 times -1 which is -1. All right. And then 6. So again, don't worry about too much about those. It's just whenever you have I, you should never have anything bigger than I. It's I or 1 or -I or -1. It's always going to be one of those 4 things. So you can never have an imaginary number with a power higher than 1, basically. All right, and that concludes 7.7. We'll see you in Chapter 8.